Bridging mathematics, so still on trigonometry. This time, unit 3, we're going now to solve oblique triangles. Okay. So again, I am Engineer Guzman. I am your lecturer for this particular topic. And in this video, we must now identify the cases for oblique triangles and use the law of sine and law of cosine to solve oblique triangles. Okay. In the previous unit, the one dealing with the right triangles, we considered the solutions of right triangles. This time, we are going to consider a more general method of solving triangles, especially oblique triangles and their applications. Okay? An oblique triangle is one that does not contain a right angle, hence, one that is not a right triangle. Consider the oblique triangles to the right. So these are oblique triangles. Okay? When at least one side and any two other parts of the oblique triangle are given, the other parts of the triangle can be found. There are 4 possible cases of problems involving oblique triangles. Okay, so oblique triangles do not have any right angles. So they can be either what? Obtuse or acute triangles. Okay, so under oblique triangles, you have your obtuse or acute triangles. As long as they do not have right angles, they are oblique triangles for now. Okay. Therefore, if they do not have any right angle, that means the formula we've developed from the last unit, the Pythagorean theorem or the Pythagorean formula, and the SOHCAHTOA or the trigonometric functions cannot be used. Again, cannot be used for oblique triangles. Instead, we're now going to develop principles that can now consider any type of triangle. Okay, because those formulas are limited to right triangles only. So oblique triangles, this will give us now formulas by the laws of sine and cosine that we can use to solve for these types of triangles. So the 4 cases. So there are 4 cases for oblique triangles. You have case 1, when you have given or when you are given one side and 2 angles. Okay, so one side or 2 angles. So angle, side angle, ASA, or side angle angle. Okay, that is a case 1 for your oblique triangles. Case 2, when you are given now 2 sides and the angle opposite one of them. Okay, so 2 sides and the angle opposite one of them. So side, side, and then angle. Okay, case 1 and case 2 can be solved using the law of sine. So we're now going to introduce the law of sines for oblique triangles. Okay, so the law of sine relates the measures of the sides of a triangle and the sines of the respective angles opposite those side. So this is a very simple formula. So it says that the ratio, okay, of the side of an angle over its sine of its angle is equal or must be equal all throughout the triangle itself. So if you take side A over sine angle A, that is equal to side B over sine angle B, and that is also equal to side C over sine angle C. Okay. If you take the reciprocal of this particular relationship, you can also do that. So this becomes just sine angle A over A, sine angle B over side B, and then sine angle C over C. So these two mean the same. Okay, so what form or memorize one, it's okay. The formula will still work. Okay, so this law of sines will now be used to solve problems for case 1 and case 2. What is case 1 and what is case 2? Case 1, given one side and 2 angles. Case 2, given 2 sides and angle opposite one of them. Okay, so let's now use this one to solve for our example. Okay, so for example number 1, we are going to solve for triangle ABC if angle A is 50 degrees, angle B is 81 degrees, and side A is 95.0 centimeters. Okay, this is case 1, yes, because we have 2 given angles and we have 1 side given. Okay, so we're going to use the law of sine. So here's the law of sine here stated here. What are our missing quantities? Okay, since this is no longer a right triangle, we no longer have a sure 90-degree angle, meaning angle C is still unknown. Okay, angle C, what else? Side B and side C. So we're looking for B, C, and C. Side B, side C, and angle C. Okay, we're going to solve first for B. Okay, so looking at the formula, again, the principle here, or what you need to develop, is to use the given values to solve for the unknowns. Okay, so we're given A, angle B, and side A. So if we relate these first two together, meaning A over sine A equal to B over sine B, what is the only unknown there? That is only side B, correct? Because we have side A, we have angle A, and we have angle B. So filling in the values, only unknown is B. Cross multiplying sine 81, we get B equal to 95 sine 81 degrees over sine 50 degrees as 122.5 centimeter. See? If you try to use here the Pythagorean theorem, it will give you a wrong value. Okay? Or if you try to use trigonometric functions, it will give you a wrong value. So don't do that here. These are not right triangles. Okay? Now, for angle C, remember, for any triangle, the summation of the measures of the angles, the three angles, must always be 180 degrees. Since we already have 50 degrees for A and 81 for B, we simply need to subtract that from 180 degrees. So doing that, 180 minus A minus B gives you C as 49 degrees. So that is the measure of angle C. Okay? With now angle C as known, we can now use the relationship of C over sine C. Because a while ago, if you relate A over sine A is equal to C over sine C, the unknown here is side C and angle C. Okay? So if you have no angle C, you have no side C. So you cannot use that yet. But since we already now have angle C, 49 degrees, we can now solve using this relationship. So filling in the only missing quantity, that is side C. Sir, you told us not to use any calculated values. Yes, as much as possible. But if the solution, okay, goes to that pattern or goes to that option, then you have no choice. If you can no longer solve for a particular unknown using only the given values, then you need to resort already to using computed or calculated values. That's why we're already using side or angle C, 49 degrees, the computed value of angle C, to solve for side C. Anyways, this is just a mere subtraction of values, so error here might be, or it's a bit minimal. Okay, so it's just a matter of inputting this in your calculator. Okay, so since we now have angle C, 49 degrees, so doing the same with B, or doing the same with C, what we did with B, fill in the missing values. Okay, so A over sine A, C over sine C. Your only unknown here is C, so cross multiplying, side C is equal to 95 sine 49 over sine 50 degrees. And that's how you solve, okay, oblique triangles using the law of sines. This is case 1, when you have two given angles and one side opposite. Okay? Okay. So, any unknowns left? None. So, that's it for this particular example. So, next, solving for the triangle ABC. So, this time, we have an obtuse angle, correct? So, the problem in number 1 was an acute angle. There was no obtuse angle there. This one, we have an obtuse angle, an angle greater than 90 degrees. What case is this? We have two sides and one, okay, angle opposite one of them. That is your case 2. Okay, we're given this triangle. A is equal to 613 centimeter. C is equal to 472 centimeter, the sides, okay, and angle A is 125 degrees, 30 minutes. We are asked to solve for the triangle. Therefore, the missing quantities will be side B, angle B, and angle C. Okay? So again, we're going to use now the law of sine to solve for the unknowns. Where can we start? So what is given? Side A, side C, okay, and angle A. I think we can relate already what? Sine angle C. So let's use this one, the angle at the top. Sine angle C over side C is equal to sine angle A over side A. Why? Because the unknowns here, or the given here, is angle A, side C, side A. So the only unknown in this equation is angle C. So if you input the values, so here it is, the only unknown is angle C. Okay? So now, isolating sine C, cross multiply, that's 472, multiplied by sine 125 degrees, 30 minutes over 613. Now you might be wondering, if you input this particular value in your calculator, you'll get a decimal value, decimal point, okay, or decimal. To get the angle, simply press sine inverse or inverse sine. So in your calculator, that is shift sine, and then input this particular value so that you'll get an angle. So you'll get an angle of decimal value as well. You should get 38.819. That is already degrees, so put degrees there. Or if you'd like to convert it into hours, degrees, minutes, and seconds, press the three symbols that I told you a while ago, or that I told you for degrees, minutes, and seconds. That is near your left side of the calculator. So if you press that, it will automatically give you an answer in terms of degrees, minutes, and seconds. So C is 38 degrees, 49 minutes. Okay. If we now have angle C and angle A was given, we can now solve for angle B by what? By simply subtracting them both to 180 degrees, because again, the sum of the measures of the angles of a triangle will always be equal to 180 degrees. So subtracting A and the computed value C from 180, we get the angle for B as 15 degrees 41 minutes. And that's already two of the unknowns. We're just missing one. Okay, so I think we can use again the sine function, the sine law here, relating A and B. So A and B, we already have sine B, correct? Yes, sine B was computed using this relationship. Sine B, take note, was computed using the value of sine C, which is a calculated value. So the error is already stacking on each other. So if you made a mistake on C, angle C, you carry that mistake on angle B, and you'll carry that mistake on side C. So we want to be as thorough as possible, as independent as possible. But if this is the only solution possible, then you might want to double check or triple check your input in your calculator so that errors will be minimized. Okay. So here, inputting the values, the only unknown is side B. So cross multiplying, this is your side B. Solving for it, you get 203.53 centimeter. That is now the complete solution of your oblique triangle. Okay, so this time we have an obtuse triangle because we have an obtuse angle. Now you might be noticing that the relationship or the values for the sides is directly proportional to the angle. What do I mean? What I mean is the larger the angle is, the larger the side becomes, correct? So take a look at here. A is the largest angle present in your triangle. It turns out that side A is also the largest side, 613, correct? So that's the rule, or that's the trend in triangles. What is the next larger angle? That is your C. Therefore, the next larger, or the second to the largest side should also be side C, which is 472. And seeing that side angle B is the smallest angle, we get the smallest side as 203.53. That is side B as well. So that it follows the trend. Okay, so a larger angle gives a larger side. Okay, those are your case 1 and case 2, which were computed using the law of sine. A simple formula, correct? So a simple but powerful formula that can be used to solve oblique triangles. However, we still have two remaining cases, which are your case 3, wherein you have now given two sides and the included angle, so SAS, okay? Given two sides and the angle that they form, that is case 3. And case 4 is now when you have all of the three sides of the triangle given. This can no longer be solved alone by the law of sine. So you need to introduce now the law of cosines. So this formula is a bit harder to memorize at first, but if you use it a lot of times, it can be memorized. Okay? So this is now the law of sine. Law of cosine for sides, law of cosines for angles. Okay? So here it says that note that we cannot use the law of sines to solve oblique triangles whose known parts are either two sides and the included angle or three sides. Hence, we need the law of cosines, which states that in any triangle, let's say triangle ABC, the square of a side is equal to the sum of the squares of the other two sides minus twice the product of those sides and the cosine of the angle between them. So in symbols, we have this. Okay, so this is now the law of cosine. Okay, it says here that the square of a side is equal to, let's say side A is equal to the sum of the squares of the other two sides. So the other two sides beside A is of course B and C. Square them, add them to each other, minus twice, so 2 times the product of those two sides, B and C, and the cosine of the angle between them. Of course, the angle between B and C will be angle A, opposite to side A. Okay, so if you want to take the value readily of side A, simply take the square root, and this is now your expression for your law of cosines for sides. Okay, if you're going to change now the variable or the side that you want to pick, just simply interchange the variable. Okay, so here are the variations depending on the side that you want to compute for. This is now the law of cosines that is now tailor-made for computing of sides. Okay, sides, you want to get sides. But this equation can be manipulated so that you can produce your angle. So if you do that, okay, so if you perform a bit of manipulation here, a bit of algebra, you can extract A, angle A, and it is this form. Okay, so if you want readily to solve for angle A, this is now the form that you're going to use. The law of cosines that is suited now for angles. Okay, so it's a formula again. So you kindly memorize just one, okay, just one formula, not all of the 6, as long as you know the concept of which is on the left side and which are squared, which are square rooted, okay, you're already okay. So this is cosine, inverse cosine, shift cosine in your calculator, b squared plus c squared minus a squared over 2bc. So notice that these two are always on the opposite side, okay, so the side that you want and its angle is always on the opposite side. So same with here. The angle that you want and its side are always on the opposite side of the equation. Okay. So we're going to use the law of cosines to solve for case 3 and case 4. Okay, let's start with case 3. Okay. Solve for the triangle ABC if side A is 25.3, side C is 13.9, and angle B is 51 degrees. Okay, so this is a rough sketch of the triangle. What do you mean by rough sketch? Because we don't really know the shape of the triangle yet. Okay, how do we know that the triangle does not have an obtuse angle, an angle greater than 90 degrees? Well, we do not know yet, right? Because we were only given one angle, that is 51 degrees. If the sum of the total, or if the sum of the angles of a triangle amounts to 180, then 180 minus 51, that leaves you with around 129 degrees, which can still be divided into 2. Who's to say that the division of 129 degrees does not give you an angle greater than 90 degrees? Okay, so this is an assumption or a sketch of the initial assumption of the triangle. And the initial assumption is that the triangle is acute, not having an angle greater than 90 degrees. But it's an assumption. So later on, if this was proven to be incorrect, the assumption must be rechanged or changed. Okay? So we're using now the law of cosines. Take note, we're using the law of cosines to solve for the parts of the triangle. We are given side A, side C. Okay? And angle B. Therefore, we are missing side B, angle A, and angle C. Okay. Side B is missing. So since this is case 3, let's look at law of cosines. This is the formula for side B for under the law of cosines. Are all of these values here present for side B? Side A, yes, 25.3. Side C, yes, 13.9. Angle B, yes, 51 degrees. So if you input this in the formula, you can readily solve for side B, which will give you 19.765 centimeters. Okay, so that is your side B. Now, solving for angle A, since we're now solving for an angle, we look at what? Law of cosines that is suited for angle. Angle A. Take note here, for angle A, it requires all of the sides of the triangle, correct? Yes, B, C, A, and BC. Okay. Now, you might be wondering, can we now use the law of sines? Yes. Okay. If you now have B, okay, technically you can already use the law of sines to solve for the remaining angles. But since we are here in law of cosines, let us use the formula provided by the law of cosine, which is this one. Okay. So for the law of cosine, solving for angle A, you have inverse cosine B squared, which will solve as 19.765, so squared, plus C squared, which is 13.9, minus A squared, which is 25.3 squared over, okay, 19.765 times 13.9 times 2. Inverse cosine. So that's very important. your calculator will give you 95.87 degrees. If you convert that to degrees, minutes, it will give you 95 degrees, 52 minutes. Now, there is something wrong with our assumption because it turns out angle A is 95.87 degrees. That means this is now an obtuse angle. That means also that this triangle is similar to our previous examples for obtuse triangles, wherein we have an angle greater than 90 degrees. So this does not look like an angle greater than 90 degrees. So you need to redraw your triangle. Okay, so redraw the triangle so that it shows an obtuse angle. Okay, now since we already have angle B and angle A, we can now readily solve for C, okay, using the relationship of the three angles that they must be equal to 180 degrees. Can you use this one? Law of cosines for C, yes. Solve for C, yes. Actually, I prefer to use this solution, but since this is the easiest one for now, okay, just to show you that they are interchangeable as long as you perform the calculations or the computations accurately, you should not worry about that. Okay, so use this one to check our answer here. So subtract both B and A, angle B and A from 180, you should get 32 degrees, 8 minutes. Okay, so this is your solution for this particular case. So knowing when to use or knowing what formula to use is very beneficial for the solutions of oblique triangles. Okay, that is for case 3. And the last case is wherein now we are given all of the three sides of the triangle. So therefore, we're just looking for all of the three angles. Therefore, we're going to use particularly these three formulas for the law of cosines that is suited for angle. Since all of them are given, A, B, and C, I suggest use all of these three formulas. Okay, so use these three formulas and you should get these particular values. So A is equal to 137.01 degrees, okay, B is equal to 26 degrees, and then C is equal to 16.99 or 16 degrees 59. You can check this by what? Add all of these angles together. Their sum must be 180 degrees. If it's not, something's wrong, but I think they are. Okay, so if you add them 180 degrees, yes. So that is now case 4 for oblique triangles. Okay, so we already have discussed right triangles and oblique triangles. The next module for trigonometry will be their applications to real-world problems or worded problems. Okay, so if you have any questions, so feel free to just repeat this lecture or ask in our Canvas or discussion page in our Canvas. Okay, so I'll see you on the next one. Thank you very much.